Okay, so we are to the last lesson in Unit 3. And in this lesson, we are going to do a mix of doing some of these problems by hand, and we're going to use the help of a matrix calculator. And I included a link to the matrix calculator in your lesson. So I'm going to kind of try to do a separate video to help teach you how to use that matrix calculator. So this lesson has us evaluate something called the determinant and apply something called Cramer's rule. Now, for the most part, in this lesson, I'm going to expect you to be able to use that matrix calculator. So once these get more in depth, rather than having you do a lot of tedious work, I want you to use that matrix calculator. So we're going to evaluate determinants of matrices by hand and with the use of a calculator. So the first one, the one I want you to be able to do by hand, is the determinant of a 2x2 matrix. And the determinant of a 2x2 matrix is you take the elements A times D and you multiply them, and then you subtract from them B times C or C times B. Okay? So the determinant of a 2x2 matrix I don't think is too bad. For a 3x3, it gets really I wouldn't say complex, but it gets tough. So I'm going to show you a 3x3, we're going to do a 3x3, and then I'm going to show you how to use a calculator for that. So in a 3x3 matrix, essentially what you do is, it's kind of like you took the diagonals of that last matrix, but you go across the whole thing. So the top left, the middle, and the bottom right, you multiply those all together, okay? And then if you did that with the second piece, you would have to kind of repeat the first two columns of this matrix. So you see how I have ADG on the outside, BEH? That's the first two columns extended. So then it's B times F times G, okay? And then it's C times D times H for that first one, okay? So you do those three diagonals, and you multiply them, and you add them together. And then you just go in the opposite direction. You start from the bottom left. So I'm going to go GEC here. All right? And then I'm going to have to use a different color for that. So just give me 1 second to find a different color to use. I guess I'll use gray for HFA. It's kind of hard to see. HFA. And then one more. See if I can actually do it. Try and use purple. The last one's going to be I times D times B. Oh, that didn't work. Thought I could use purple. There we go. So IDB. And you multiply those and add those together. And you subtract those two sums. So that's a lot. I'm going to show you that for one matrix, and then past that you're going to use a matrix calculator. So the determinant for example 1 is just me multiplying 4 times 2, so 4 times 2, maybe I'll use parentheses, 4 times 2, and that'll be minus 5 times negative 3. So the determinant of that matrix is really 8 plus 15 or 23, okay? So the determinant of that matrix is 23. Now in this next one, you're going to have to follow closely because it does get a little tricky. So the first multiplication I do, and I'm going to use a parentheses for this, is 1 times 3 times 6 plus, and then this is where we've got to extend it. I'm going to extend this matrix 1, negative 1, 0, first column. Second column, 1, 3, 2. So I'm going to highlight 1 times 4 times 0. And then I'm going to add, and then the last one, 2 times negative 1 times 2. Okay? And for the sake of room, I'm going to subtract, and I'm going to use blue for this next one. I'm going to subtract from this whole sum. I'm going to subtract. It's going to be 0 times 3 times 2 plus 2 times 4 times 1 plus 6 times negative 1 times 1. So to rewrite all of this, the first sum here, this is going to be 18 plus 0 minus 4. Okay? That's just me doing this order of operations. The second one is going to be 0 plus 8 minus 6. So in the end, the math I actually do is going to be 14, that's this sum, 18 plus negative 4, minus this sum, which is 2. So the determinant of this matrix is 12. Now again, that's tedious work. I'd say if we've got a calculator and we know how to use it, I'd say we use that to find the determinant, okay? So what I want you to be able to do, I just want you to do this guided practice number 1, okay? I know on the next, so just pause the video, try guided practice number 1, and then I'm just going to have you do some practice, some of the practice after this, instead of going to the end and doing the whole practice. So after this video, you're actually going to do a little bit of the practice. So pause it, check your solution with me, and then I'll have you move on. Okay, so this determinant is the one I want you to be able to do by hand. You know, multiply those diagonals. I don't think that's too bad. So multiply 2 by 7, multiply 3 by negative 4, subtract them. It becomes 4 plus 12, which is 26. So what I'm going to do next, I'm going to show you a new system, or a new way, new method to solving. I'm going to erase this first because I wrote this too early. I'm going to show you a new method for solving a system, a 2 by 2 system. Okay, and this is called Cramer's rule. So with Cramer's rule, we are going to create something called the coefficient matrix. Okay, so the coefficients are A and C and B and D. Those are the coefficients. So the coefficient matrix of this system, we're going to use A to show that. It's going to be A and B, the coefficients for the top system on the top, and then C and D. So essentially, the numbers multiplied by x, the numbers multiplied by y, form a matrix. That is the coefficient matrix. We find the determinant to help us find the solutions. So what happens is, I'm going to try and color code this the best I can, but the coefficients for x, A and C, the coefficients for y, B and D. Okay, so for us to solve for x, we need to have the coefficients of the constants E and F be our first column in this matrix. The coefficients for y, B, and D be the second column in that matrix. So we find the determinant of that matrix we make divided by the determinant of our coefficient matrix. For our other solution, y, it's going to be the coefficients for x, meaning A and C here, and then right here, the solutions, the constants E and F. That should be F. So I'm going to cover that up, and I'm going to say this should be F right here. So I'm going to give you an example on how to solve this. You're going to have to kind of pay attention to what's going on. So you're going to be able to see your little diagram or steps up top. But the first thing you always do is you find the coefficient matrix. So that's going to be 3, 2, 2, negative 7. And I'm going to right off the bat find the determinant of that matrix. So that was where we did, multiply across and then subtract those values. So negative 21 minus 4 is negative 25. So that is the determinant of A. That is going to come in handy when we solve for x and solve for y. Because what happens is we divide by that determinant to find our solution. Now the matrix I set up, it's very important we know how to set up this matrix. The thing that comes first is our constants, negative 4, negative 11. and then the coefficients for y, which are 2 and 7. And we find the determinant of that matrix. So that's negative 28, negative 4 times 7, and then negative 11 times 2, which is negative 22. And that is divided by negative 25. So this is negative 50 divided by negative 25. So that makes x 2. Okay? So, setting up a matrix with your constants as the first column, and then your coefficients for the opposite variable, for y, the second column. Now to solve for y, I'm going to use a different color. I'm going to use blue, and that's still over that determinant, negative 25. The matrix I set up here is going to be 3 and 2 in the first column, and then my constants, negative 4, negative 11 in the second column. So I find the determinant of that. 3 times negative 11, 4 times negative 2. So that means negative 33 minus negative 8 over negative 25, which this becomes negative 25 over negative 25. Y is positive 1. So my solution in the end is the point 2, 1. I'm going to do a better job of that. So it's setting up a fraction, actually two fractions, and finding the determinants. And setting up these matrices can be hard. So you're going to get a quiz. It's going to be virtual, meaning it's going to be open note, meaning you can use these examples on that quiz this week. So just keep that in mind, that this quiz, us being virtual, it's going to be open note. So these examples are going to be kind of important. So the last example I want to show you in this video is just the second guided practice. I'm going to do a whole separate video for an extension, if you want to extend this lesson, to show you how to use a 3x3 system and so use Cramer's rule to solve a 3x3 system. So I'm just going to go right into the next guided practice, and actually I'm going to pump my brakes here. I want you guys to solve this on your own as much as you can, and then check your solutions with me once you think you are ready to check your solutions. And then you can look through, you can look it over and compare your solutions to mine. Okay, so for the guided practice, write your coefficient matrix, find the determinant. I got that determinant was 7. So that means in both of these fractions, I divided by 7. That was on the bottom of each of these fractions. So that's an important thing for solving. For me solving for x, I put my constants first. So the first column of this matrix to solve for x was 4 and negative 5, and then the coefficients for y, 1 and 4. Okay? So it's kind of like you're replacing x with these as solutions, all right? And then in the second matrix, it was like I was replacing y with these as solutions, okay? So then I did my determinants, I did my dividing, I got the 0.3, negative 5. So the process, it's a little tricky at first, but I think once you go through some practice problems, you start to see the pattern, and then it starts to get a little bit clearer on how to set them up. But again, keep referencing this. Keep referencing this thing at the top, this how to set up, okay? And these problems. Hopefully I laid them out organized enough for you to be able to follow, but that's the main thing. I expect you to know how to use Cramer's rule to solve a 2x2 system. I can show you how to use a matrix calculator to I'll quit flipping around. But the idea is you know how to solve a 2x2 system using Cramer's rule, all right? So you can move on to the quizzes. That is going to serve as your practice. That is what's going to go in Infinite Campus as a grade, you completing the quizzes in the next step. So use your real name, do it completely. That counts as your practice, you finishing that. Whatever you get right, whatever you get wrong, as long as you answer every question, you get credit for your practice on the quizzes. If you choose, you can do the paper copy of the practice on a separate sheet of notebook paper, and if you want that to count towards your credit for the lesson, go ahead and do that. But I'm saying I'm requiring the quizzes because I think that that's going to be easier for people to complete rather than the paper practice. So I'm going to try and be a little bit more lenient with that. I'm going to encourage you to do the paper practice, but if you would rather have that count towards your practice, you need to let me know. So through this virtual stuff, You have to communicate. You have to email me. You have to reply to emails for this to work at all. Please, please, please check your emails. Please check Classroom daily. Please respond to things I send you. I am going to help you as much as I can, but that communication is vital to this working in any way, shape, or form. I don't care if you're behind, if you're ahead, I don't care where you're at. Please communicate with me so that I can still teach you and still be in contact with you, because it is going to be super painful when we get back if you take these 2 weeks and do absolutely nothing. It's going to hurt you, it's going to hurt me, it's just not going to be a good situation. So please, I am going to work with you, I am going to help you, but you have to reach out, please. I am pleading with you to do that. Thank you. Thank you for being patient through all this. Thank you for working. Thank you for doing your best. But please communicate with me. There's a whole nother page for that. A little bit later. 3x3 systems. So I'm going to show you that be a separate video if you choose. It'll be optional. Okay, it'll be optional. But